Great, thank you. Right. So Wes, why don't you introduce yourself, and we'll go around the horn.
Sure. Wes Barlow. So I'm a senior data scientist at USAA, where my concentration is on supporting HR and employee research, kind of leading our advanced analytic efforts. So lots of, I guess, ever increasing amount of NLP being used in there. So educationally, I am I guess more on the psychology side than computer science side, though I've done both computer science, math, and psychology kind of as you build up, and a lot of our stuff is very ties into a lot of kind of IO psych themes.
Awesome. Jennifer?
Sure. I'm Jennifer Klemisch. I work for our test evaluation organization for the Boeing company. And my role is the Advanced Analytics Strategic Leader. And so we are looking to find a strategic direction to implement all kinds of data science models within our organization to optimize how we do flight test and how we do our lab test. My background is initially engineering, and started up as design engineer on the 787, and then did quite a bit of work as a flight test engineer. And about 7 years ago, I tried to figure out what I wanted to do when I grew up, and really said, well, the thing I've enjoyed the most, even if it's, I was maybe on a flight test and doing wind-up turns or stalls, is I actually like making the data more visual and easy to understand. And so I decided I should go into data science. So I got my degree in data science, and about 5 years ago started doing more natural language processing modeling, and I think there's no turning back. So that's where I'm at.
Awesome. And Johann?
So I'm with Levatas. I'm the Chief AI Officer. I've been working in the industry for over 20 years, so that's giving my age away. Back when I started, it was a lot of web development, late 90s. And the closest I could get to AI was symbolic, and it didn't really, attract me, the symbolic nature of things. So as things advanced over the years with deep learning and all of that, there was like a renaissance. And, I became more involved a couple of years ago, went back to school, got a degree in cognitive psychology, got another master's in data science from Northwestern, and, just spearheaded some of the projects at my previous company. And with all of that, it's been one of those things where as you learn more, you realize that there's so many different areas. So right now, my core focus is really at our company is predictive analytics, machine learning, natural language processing. So I would say those are the areas that we specialize in.
Great, thanks. And I'm JT Wolohan. I'm a AI solutions architect for Booz Allen Hamilton. My focus is on natural language processing and analytics delivery. So what we do is we work with our clients and we help them understand how we can use natural language processing to solve their problems. And then we go and we build those solutions and we deploy them. So I oversee natural language processing efforts and web development and everything in between. Do we have a first question? All right. So Jennifer, let's start with you, and you can kick us off with an answer to what are the requirements for an organization that wants to start doing natural language processing, and at Boeing, where have you guys started focusing on natural language processing?
I'd say that a couple ways. Where we've tradition or not always have started, right? It takes a little bit to figure out the best process. But starting with the team, right? You bring in your instrumentation engineers, bring in the data scientists, but also bring in the subject matter experts, the ones that help curate the data and that are going to end up working with the data in the end, and working with your models and owning your models. So starting with that core group, excuse me, also having a customer representative, and especially the sponsor. It's so easy to have the technical community get together and not have the sponsorship engaged from the beginning. So starting with your team and really identifying what do you want to do with the natural language processing, or any model for that matter, right? What questions are you looking to answer? Can you actually write out the question? Can it get it back clear? From there, consider if there's already applications that will do what you want to do, right? Are there, if you're looking to do analysis of charts or graphs, right? Go get software that will do that, because it'll do it better than you do in-house. If you still need to do an in-house model, a lot of what we do are we're mixing engineering with natural language processing, and there's not a lot out there with that physics-based modeling to begin with. So from there, we actually start with the data science hierarchy of needs and identify gaps in the structure. So do we have the data? Is it being stored? Is it accessible? A lot of times with our data, at least, they're in different systems that were developed maybe 40 years ago, so accessing the data may be challenging. So we start with finding out the basic levels, the foundation of the hierarchy of needs, and identify those gaps. We start with MVPs. We do a number of hackathons internally, so we can get to a minimal viable product. And then we improve the architecture as the questions get more challenging. So make that an iterative process. And then as we go with each problem, we really try to identify what the objective is. It's easy to get lost and try to do too much at the beginning. So taking one step at a time with each problem.
Johann, and I imagine that you've been in AI for a long time, that you've seen a lot of organizations try to start the process of getting into NLP. What are some of the success stories you've seen there, and the organizations that do and start up NLP well? What have they done?
So I would say one of the first things that we always try and do is do like a data audit. We want to see what data is available, but not just available, also is it consumable? Is it, what's the quality? So I'll give you two examples. I like to kind of give you one success and one really bad one, just so that you can kind of contrast, right? So we did a project for a company that had a recommendation engine that was existing. They didn't want to change that out. And they wanted to add some natural language interface like a chatbot to make recommendations and kind of, coerce in a soft way somebody to maybe purchase, upsell, cross-sell of products. The problem we ran into is that NLP was not the problem. It was the recommendation engine that ended up really making the product not very useful. Switching a little to a good use case, another company, same kind of situation where the recommendation engine, and back to what Jennifer was saying about just the data. This company, even though the project overall was successful, we started off with no data. All the data was basically stored in menus. So if you think about that, you had to do OCR, extract it, digitize it, tag it. But ultimately, we had a backend system that made really good recommendations. We tied it with a third-party data source for like food specific ingredients. And we made it pretty rich, where most people's experience with chatbots aren't really great. This was a very narrow focused, very specific type of application. So to boil it down, I think if an organization wants to succeed, the first thing they need to do is understand their data, understand how they either going to utilize it, or if they're not at that point, how they're going to capture to utilize it later.
Yeah, that's great. Wes, do you have similar experiences?
I do. I guess one of the big things I would probably press on were some of the comments that Jennifer made around understanding the business objectives and the requirements around it. Because as a data scientist, I think in general we're very curious, and we get excited about new challenges and new things, and you can get really stuck maybe chasing something down that really isn't going to meet the real goal, especially using some of these more exciting and new methods that are coming out. But kind of understanding what the business really needs in the beginning, and whether or not NLP is really the right avenue to go to meet that objective, because it is new and neat, and we do enjoy doing it. But we've definitely had instances where, as you really refine what the requirements are, you find out there's a much better solution that is not what kind of the current I guess whatever buzzword that has been pitched to the executives.
Yeah. I think there's a really good trend kind of, brewing all across what the three of you have said with, starting with the problem, the business problem, and then working back into a data science problem. So you don't necessarily want to start with NLP as the answer, unless the question suggests that, right? But there is, if you've identified NLP as the answer, there are requirements that you need to have, right? You need to have some textual data to work with. Is there anything else you think that folks would need, Wes? I know Jennifer mentioned a team of data scientists.
One I'll go with is an understanding of the population that's going to be writing the text you're going to be analyzing, because you can use some general models or things that are built outside that, if you're like, most of my work is done with an organization, so with employees. And within our organization and with any large organization, you have kind of your own language. And even within the organization, you have little sub-dialects where, so bringing something maybe externally or trained externally may not be appropriate. So we've had instances where you have names for things that are, if you were to bring in like a sentiment engine that's looking for positive and negative words, that would, you're using it as a proper name, but it sees it as being a positive term or a negative term, and kind of makes your model output janky from a sentiment standpoint. And so you need to kind of build, the closer you can get to building your processing around the population that's going to be using the tool, the better off you're going to be.
Yeah. And Jennifer, you mentioned kind of the tension between using either commercial software or free and open source software, or building a solution in-house. How do your teams address the question of, should we bring in maybe an open source or a public model or somebody else's model, or even a benchmark model for a task versus, should we train our own model for this task?
So within Boeing, actually, our access to open source models is fairly limited. So that actually makes that question pretty simple, because it's either you buy something or you make it in-house using open source code. We're starting to move in that direction. We've had to put quite a bit of infrastructure in place to ensure that we can use packages, at least, from open source systems, but that's only been fairly recent. Because of the customers that we serve, government customers, international customers, and the various type of restrictions that we have. Not to mention that all of our work in some way or another needs to be certified or validated. So relying on open source code is pretty few and far between. And so we do things, either purchase a COTS application, an off-the-shelf application, or build an account.
Interesting. So Johann, across your experience, what are some of the top examples of NLP models that you've built or you've seen built in your time in the industry?
So I would say one of the most exciting ones was a cognitive training solution. It's pretty boring when you think about the application for it, but I find it very exciting because it's given so much opportunity for other analytics to happen. So a big energy company came to us, and in partnership with IBM Watson, we actually set up a process where we had a solution that allowed for plant managers. So if you think about nuclear plants and such, to draw proactive insights out of condition reports. So these condition reports tell them, overnight there was this and this and this that happened. Somebody puts it into a computer, so it's digitized, and they're able to see actual graphs and stats pulled out of that. So just being able to take language, from reporting and turn that into something that they can actually share with business folk was great. Another example, and it was one of the first projects that I worked at for a big security company, was just the amount of savings that they got from a very simple application was tremendous. So if you think about spell check, it's very good at capturing words and stuff like that. But if you have to put it on steroids and add AI and NLP to it, there are certain security incidents that happen. Let's say at the mall, a security guard catches somebody stealing something. They have to write a report. A supervisor then has to review the report to make sure there's no social security numbers or other PII information in there. Or it could be that they do need to capture a first name and say who's the victim, the perpetrator, stuff like that. So there's all these rules that goes into a report that a supervisor needs to analyze. So if you imagine you're a multinational company and every supervisor spends 15 minutes on these reports, and you can cut that by 5 minutes or 10 minutes. It's just a huge amount of savings. So things like that is really, it's boring when you explain it, but the ROI and the business implications are pretty tremendous. And then, of course, chatbots, virtual concierge. A lot of that over the past, I would say, 5 years has been pretty prominent. And different iterations where you have your, like a Clippy, which we all love and adore, but not. And then you also have these smart engines that's just enable you to use natural language to search huge amount of data and text. So, that's like high level, some of the exciting use cases. There's some other we'll probably get into later, where I see the future going. But for now, I think that's hitting the top ones.
And Wes, what are some of the most exciting uses of NLP that you've seen?
So within, most of the work that I do personally is around theme and sentiment detection, since I'm primarily looking for employees, which isn't incredibly exciting by itself. However, the doing it within HR of a large organization that's a large insurance company, as well as being considered a big bank, definitely adds some complexity to it. And from a compliance and regulatory standpoint for review and documentation required for the things, but then also from HR, from a standpoint, especially around text, if we're working on something potentially like for talent recruitment, our model is not potentially disadvantaging employees based on race, ethnicity, or gender in the language that they use. That it's not potentially putting down a different pipe based on those. So there's an extreme amount of work done, not just in the model creation, but then on the back end for validation and making sure that it's not discriminatory in some way. Which in NLP, it's a thing. People use language differently, and sometimes those differences in language divide across ethnicity or economic backgrounds, and you need to be careful that what we build isn't I guess furthering that type of discrimination.
Yeah, absolutely. I know there's a whole subfield of NLP dedicated to de-biasing these models and taking the kind of the state-of-the-art models that are built on open source web data and trying to undo the problems that we have using language in an unbiased way. Jennifer, hopefully, Boeing isn't dealing with any of that in their engineering reports, but maybe they are. What are some of the most impressive examples of NLP you've seen?
Right, a couple different avenues. We've done some NLP to extract content from all of our test reports. The way that we've traditionally done it is each test engineer that was on a flight is writing manual notes. That's combined with configuration documentation and instrumentation documentation. And at the end of the day, each different organization writes summary reports. And then you've got this compilation of all of these reports and documents and compiled together. In the past, in order to go back and maybe you're working on some troubleshooting to find out what happened, you're trying to potentially identify all of the cases when the pilot report gave you condition comments, or maybe you're just looking for every takeoff and landing that you've done on a particular test flight. In the past, we would have had to look at that all manually. So you're looking through about 50 pages of notes per flight. And so we've pulled all that in using a Neo4j graph and put some NLP on there to extract that information and allow you to actually search it. So that's been extremely valuable. It, again, like Johann said, it doesn't sound really exciting or sexy, but it sure has a ROI in reducing the amount of labor that it takes to do troubleshooting. Some other cases we've done, I'm currently working on an application where we've got our technology taxonomy, and we're matching that with the SMEs in the organization. And so we have an internal social media site which allows you to post articles and put your resume, do a bio, do your skills. You may be able to answer questions, technical questions, and provide responses. And so the natural language model is looking at all of that profile content, and we've set up different criteria to match those profiles with technology terms. So we can automatically identify who are the SMEs in the organization, based on each technology. So this was some more recent examples.
Mm-hmm.
Also done some safety analysis work where we've matched if there's a workplace safety incident, the manager types out what happened, and then what the mitigation was. And then they also identify using a drop-down box what the root cause and the mitigation category was. And what we found through analyzing manually the information, found that there was actually a discrepancy. What they wrote didn't always match with what they selected. Mm-hmm. So the natural language process model did some classification of the incidents and find trends and do topic modeling there. And then we were able to actually identify that we needed to go back and train the submitters on how to select a root cause. And then we also changed the system so that it would allow the same type of categories that were being selected. Otherwise, it was giving us skewed results. Mm-hmm. Anyway, a couple of examples.
No, I think those are great examples, and I think you can see a trend across all the examples that all of the panelists provided. Right? Is NLP is really a way to augment the capacity and volume of knowledge workers. Right? We live in a knowledge economy, right? And it's good for all of us data scientists, right? That we do. But the more we can expand on the ability of those knowledge workers to do their jobs, the more we can automate the unstructured information that they consume to do their knowledge work and that they produce as a result of their knowledge work, the more organizations are going to benefit. And all that work has to, by definition, be done by natural language processing, because you can't codify it well enough in a spreadsheet, and nobody's going to take the time to do that, even if you pay them. So, so Wes, how should data scientists select when to use deep learning approaches versus the more traditional machine learning approaches? So maybe like a linear approaches, or think about things as like deep learning and then everything else. And how do you pick?
Okay, so so I guess I'd keep things like LDA and some of those things as more traditional machine learning approaches. So for us, it comes down to, I guess, if I gave one word, it'd be volume, which unfortunately in my space, doing primarily employee research, that's not really the question that we do. Is usually between machine learning and deep learning. Our big question is usually between human raters and machine learning. Because of the volume, because if you're dealing with a really low volume, sometimes the best thing that you can do is if you have people with some capacity is you read it, because we're pretty good, but I mean we're not perfect. And that kind of goes to me. So last year, kind of a way to keep the blades sharp, we participated in a CAIO machine learning competition that was focused on NLP. And so we went through and we did well enough to get in the winner's circle we were trying to predict personality based on answers to interview questions. So it was about 1,000 responses that they had to interview questions. And so we get there and, we're in the winner's circle, but the number one team beat us pretty handily. We weren't that close to what their final accuracy rate was. And then they get up there, we get together and they start talking about it. They had a staff psychologist that read the comments and then marked his, and that was one of the variables in their model, which on one hand, I don't see how that's a machine learning competition that you can, we don't have a package for the psychologist rated my items, but not that I'm bitter. But in truth, with volume that was that low, a human reading it was, that was an edge, and there was nothing that, we iterated quite a bit and moved to LSTM techniques, and we did some deep techniques on it, just trying to see what we could squeeze out of it. And we just weren't. We got a lot more familiar with GLOVE or global vectorization, which was kind of fun to go on that path, because in our regular life, since we do have to explain how everything works to regulators, we're kind of limited on, for us, there's a lot of extra cost if you want to go deep. In documentation and then in explaining how it works, since we have to be very clear and I guess clear, not just that we understand it, but that we can write it up in such a way that the regulator is also going to be able to understand, which can get really complex. So if we're able to do something not going deep that can get us most of the way there, for us, that's a cost savings in labor and time for not having to go to that TP, even if that TP gives if it can give us a couple more points on accuracy.
And Jennifer, it sounds like it's probably a similar situation for you. Is that right?
Yeah, absolutely. Having your models be explainable may cut out a number of being able to do any deep learning at all, right? If you can't explain it, if you can't actually show what's happening, then you might get the best accuracy out of it, but it's not, you can't actually use it. The regulator piece is really critical. And just kind of add on to that, when I'm starting a model, I actually like to start with pen and paper or a whiteboard and manually look at my corpus and see if I can do what I'm asking my machine to do, right? Take a couple paragraphs and see if I can do a classification. Make sure I've got the right data to even start with. And so in the way you could actually say that's a very traditional model, right? If I can understand the complexities in my data and understand the behavior of the data, then as I do start to go into the deeper neural networks, I'm going to be able to identify if something's going to skew, or at least be able to understand and validate what's happening there.
Yeah, absolutely. Johann, what do you find between, is there a tension between deep models and traditional models? Are there certain specific use cases for each, right? We've heard that there's a clear use case to set a baseline, as Jennifer pointed out, less and more clear is better. And as Wes pointed out, if you've got a regulator that wants to be able to, have you explain, it's harder to use deep models, right? Where a lot of things get, masked in the neurons. But maybe what are some of the really good cases you've seen of deep learning approaches?
So I think I agree with Jennifer and with Wes. Some of the limitations that they have, we see with our clients as well. Just being able to explain the model, and then also data. How much data do we have? Those are definitely two factors that determines it. Another one is also when our team is, we're applied data scientists. We're not going to come up with a lot of algorithms because our clients don't want to pay us to solve, to build an algorithm. They want a business problem to be solved. So, obviously we try and get there as quickly as we can, and also with the available data, resources we have. So a lot of times what will happen is, let's say we have enough data, then the deciding factor is, do we have access to GPUs, for deep learning? And I'll give you an example. One of the cruise lines, we actually did some work for them. And you can imagine if you're out in the ocean on a cruise ship, your computing power is very limited. Having GPUs available in the cloud to spin up and do training and all that, it's not feasible. So you have to, kind of look at what is the restrictions around it. Another example is also we work with Boston Dynamics. We're one of their partners for the Spot robot. So, we have neural networks and things running on top of that. It's pretty expensive, if you have to put a lot of those kind of units together. So just knowing if it's edge computing, if it's, cloud computing, the amount of data that you have. And then for myself, I still do a lot of modeling. If I'm experimenting, just testing hypothesis, a lot of times I'll pull out Python, NLTK, Spacey, and I'll bang away and kind of see what results I get. But it goes back, I think Jennifer said it earlier, understanding the business requirements and then understanding the data is probably the first factor, before you even get to what kind of network or model architecture I'm going to pick. Having a clear understanding of that is important. So typically that's pulling out Spacey, NLTK, and Python in a Jupyter notebook and just playing around, or on a whiteboard, just sketching it out.
Yeah, and I think, you bring up the cost of running some of these deep models, and it's, it's important to emphasize that can be a really non-trivial issue, right? The cost difference between, running, say a naive Bayes model in parallel on a CPU versus a deep model on a GPU, if you're using AWS for both services or Azure, can be a non-trivial difference, and your data set grows, both the time it takes to train and the cost really have to justify better results. Johann?
Just to add to that, what you're saying, one thing that I've seen, and this is kind of sharing what I see out there, very rarely do we solve a business problem just with off-the-shelf models where it's pre-trained, and somebody can just say plug it in and it works. That's a good, like if you do a hackathon, if you do an MVP or MBT, that's a good way to kind of answer that question, that it's feasible. But actually solving the problem, a lot of times you have to do custom training. And that starts with maybe creating ontologies, and that takes time, taxonomies, things like that. So it's just, my experience has been, if we want to quickly show results, deep learning has its uses and it's got its place, but nothing beats the whiteboard and just a couple of the simple models to test that out, and then invest the time, go get the budget, to come back and say, okay, now that we proved it out, let's invest in this because we know there's potential. And then I've also noticed then it becomes less of having to explain the models. It might be different with regulators and HR and things like that, but at least with regular business users, once you've given them the confidence that it's possible, you don't have to explain as much about your model and how you do it. It's more about what problem you're solving.
Yeah, and Jennifer, it sounds like Johann is saying a lot of what I'm hearing you say, right? With this notion that when we're building out analytics, we don't want to build out the best natural language processing system. Step one, right? Step one should be what's an MVP? How do we prove out the concept? And is that what you all do at Boeing?
Yeah, absolutely. One of the things that we found with doing that is that what your director or your VP may be expecting, the look and the feel of the output of the model, may not be what your subject matter experts and your technical community is looking to get out of it. So by doing those MVPs up front actually allows you to then have that dialogue and determine where you want to go from there. Is it valuable to get the look and the feel of the data of both perspectives, or do you really need to come together and merge what it is that you want to get out of your model? So starting that, and I really like how Johann mentioned about the expenses, right? And sometimes, like within Boeing, we're just now having an internal cloud, right? So and we do a lot of remote work as well, and the expenses and all that makes a big difference. So it's excellent comments there.
Yeah, absolutely. And Wes, I mean, do you find similar issues with it USAA? And this can tie into the next question. So Michael, if you want to put it back up on the screen. Jennifer mentioned that there are these, all those multiple value propositions with your models, right? There's models to your executives, there's models to, whomever the other customers are, assuming they're not just your executives. And then you have to balance on the third hand, kind of all the traditional metrics that we're taught to pay attention to in kind of like data science world, right? Like how do I balance precision, recall, and all that? What do you pay attention to when you're trying to assess the value of an NLP model?
Well, I mean, there's quite a few. There's quite a few. So one of them is, I think that we covered a little bit earlier, that you look at you're essentially automating something that could be done by a human. So there's kind of a cost benefit analysis that you can run there, and also depending on the expense it's taking to run the model. I mean, that obviously falls on the cost side. So there's more of a traditional business financial approach to it. But when you're looking at the value, I mean, there's also the quality factor in there, which NLP is a tricky animal. At least in our world, for theme and sentiment, when we're looking at more employee comments, that can be a tricky thing. Because when it comes to accuracy and precision, I mean, so to jump more to my psych background for a bit, even human raters that are doing theme detection, like graduate students that would do when they've done studies where they kind of cross-validate, they agree about 85% of the time. So a human that's trained in a technique are going to disagree on themes and sentiment about 85% of the time. So you need to kind of understand that when you're going into these theme and sentiment detection models, that if you're getting kind of nebulous topics that are going on, you're gonna miss some. And so what we've done from a more, I guess, practical level is we do have kind of a process where we have humans do some validation, some kind of ongoing validation, where they'll take a sample and go through and see if it's see if they agree. And to do that correctly, you need some diversity when you're doing it. It can't be a person, especially not the person that built the model, which unfortunately is what happens sometimes, because then you're just taking your biases that went into building it, and then you're adding those again when you're doing your ratings. And then to give a sense, and also to kind of level set around when you see those accuracy and precision numbers, and to have them kind of understand from a business standpoint that if you're getting accuracy of 60%, and that's actually like a validated accuracy level of it picking the correct theme, that's pretty awesome. But they need to kind of understand that, because they might look at it and be like, ooh, because if you had, if that's how your algorithm that was choosing whether or not to give somebody a loan was performing, then that would not be awesome. That would be pretty bad.
Yeah. And Wes, I think you're alluding to something here that I think is one of the really interesting areas of NLP, right? I mean, one of the reasons that I'm sure all of us are drawn to NLP is that there's this, possibility within natural language processing to do things at a scale that people can't, right? That we can do, complex cognitive tasks at a scale that people can't do. And that offers organizations a value proposition that they can't traditionally put, cost to, right? Because they could put cost to it in the terms of people hours, but you would never even think about how many people hours it would take to do such a human heavy intensive task, because you might be able to replace an office full of people with an algorithm in some instances. Johann, what are some examples of natural language processing that you've seen that kind of bring value by expanding the realm of possible for an organization?
So our focus, working for clients is always to bring value quickly, because we're basically getting our next lunch if we do a good job. So we also, over the past, I would say 3 years, we've actually patented in the computer vision side of things. We've patented a process, and you can actually apply it to NLP as well, but we focused on CV for now. But what it does, if you look at a model and AI in general, it doesn't really know when it's wrong. If you think about your kid, when they grow up and they learn about something, they might come to you and say, hey, Dad, is this, they'll ask when they're not sure. Whereas AI is very, they'll have a confidence of maybe 40%, but they're going to give you an answer. So they don't really know when they're sure, when they're not right or not sure about something. So we have a process around that. And part of that is also taking that haystack. And I think Wes was saying it. If you have so many or so much data and you have to shrink it and get a human in the loop to help validate it, that's valuable. So adding value, we try, and this is one of the jobs that I have, at our company, to get our data science to talk about, what's the implications of a model. If I have true positives, true negatives, false positives, things like that, what is the implication to the business if those values go up and down? We try and talk about that rather than, what's the accuracy and precision. That's internal, how we measure the success for the model, but that doesn't explain the value. The value comes from ROI. It comes from, what's the business value that it delivers. And, a lot of what we've talked about so far, I think it's becoming clear, we're not replacing humans. What we're trying to do is we're automating and we're shrinking that haystack to try and get people to be more productive, more intelligent, and just make smarter decisions overall. So I think value is really objective from that point of view, because every project will have a different value attached to it, but it's very rare going to be a accuracy or precision score. It's going to be some other value that you're going to have to derive from it.
And Jennifer, it sounds like that's going to be the same for you all at Boeing. But do you have any experience working with and monitoring kind of the value of these NLP approaches over time, right? And maybe if we're talking, you've talked about the importance of doing iterative development, starting from an MVP and scaling up, right? So how do you know when to stop, right? How do you know when to stop scaling up and say, okay, we've got enough value out of this. Let's stop spending data scientist time on this. The model's good enough. Let's go do something else to add value.
Right. I would actually say that starts at the very beginning, right? After you've identified the question and identified why it's valuable for them to, for your customer to know that, and you're identifying before you've even touched your computer what actions they're going to want to take out of your model. Start with that, and then if you're identifying upfront what success looks like, then making that decision later about when to stop becomes really easy. You may put it in terms of precision and accuracy, but I definitely agree that if you're talking about precision and accuracy with your end customer as your primary measure of success, you've probably missed something there, right? If your subject matter expert agrees with the output, if they validated the output, then you're increasing not only their buy-in, that they will use the model and they will own it going forward, but also that it's adding value and either streamlining or automating the work that they were doing. Or maybe it provides new insights. It may be providing them information to make decisions that they didn't have. And you can't really put a value on that. You can put, identify with the value in terms of labor hours to do something manually. And I've done that before. I sat down and I took a bunch of data and I analyzed it and did reports on it and measured how long it took me to do that work, and then showed what it would be to use modeling procedures instead. And just that pure number of doing it once, when people saw what doing that analytics provided, that it wasn't a replacement of what's been done before, it was just new access and new information, enabling them to make new decisions, that became more valuable than just the labor hours.
Yeah, I think that's exactly right. Bless you. And one of my big design philosophies around natural language processing and AI more broadly is that the more we can kind of hide the internals of what these things are doing, kind of the opposite of this, explainable decision making, is, if you don't have to see that a decision is happening, and I can just provide you good results, and you can just trust, over time, you just learn to trust that those results are good. More often than not, that's going to produce a better product. And you think about tools like spell check or Google search, and these things are wrong, with reasonable frequency, right? We've all typed things into spell check and been like one letter off and gotten ridiculous suggestions, but most of the time they're pretty good. And we don't really mind because they're small, right? So it's a lot of NLP trying to solve a small problem that can add a lot of value, and the results are good enough, right? And so as we've been kind of talking about on this panel, there's some threshold of value that you need to cross where it becomes good enough, and then once you reach that threshold, you can stop, because you don't have to get everything perfect. And this is one of the biggest challenges that data scientists have transitioning from academia to industry, from AI, academia to industry, is realizing that in industry, right, at Boeing or USAA or Levatas or Booz, we're not chasing after that last percentage point. You just want to solve the problem and move on to the next problem. You got a lot of interesting problems to solve all over, right? Johann?
So the one thing that, I want to kind of ask the other panelists as well, we follow a hybrid approach to like crisp VM, and I don't know if you guys are familiar with that, where you have your 6 stages, and that business and data understanding that happens in the beginning is critical. We also have a checkpoint at that point where we say, okay, you know what, now having looked at the data, understanding what the business need is, how do we actually now implement it in the time and budget given? So, those, just being able to wrap that up and get it into something that's explainable up front, where you have, you can explain back what the problem is and how it fits together, is very important. And it has to match the data.
Will you describe the process for those on the call who
Sure.
might not know? I know we've got 100
right.
participants on the line, and then Wes, I'll kick it over to you to follow up on that.
Okay, I'll just quickly run through the 6. So you have business understanding, data understanding, And if I'm a little bit wrong, please, anybody jump in and help. You have data transformation, you have modeling, and you iterate on your modeling. And this is where you were saying, JT, when it's good enough, you have to decide when you do that initial check-in, what is good enough. So when it's good enough, you do your validation. And then that validation also goes against your business use cases to make sure that you're meeting the actual business use case during validation, and then deployment. I think that's the six phases for crisp DM. And there's obviously others.
And Wes, do you guys follow a process like that at USAA?
It's somewhat similar. It's just ours. It really, the big checkpoints for us are some external reviews that occur. We have, so as part of a model risk management, there's sort of an external peer review process that we also go through that's integrated into that. And then our implementation and development teams, implementation, development, and to some extent validation are different groups. So a lot of our time sometimes is getting on their calendar. So we're, we've segmented it in such a way as one of our kind of control checks that our developers and our integrators are not to be the same groups of people. So for us, that evaluation to deployment, in the middle, there's getting on their calendar and getting on their priority list, and then working through the things as more adjustments are needed. There's kind of a deployment can go back and spin off another cycle and so on if there are changes that need to be made. Say if we get with a deployment team that if we're working in R and they really like Python, and we're like, now we have to go back and redo this thing in Python. And then we have to get our documents revalidated and updated. And it's just a lot of, there are things that can spin off there. But other than that, we mostly follow this because this is kind of a natural, I don't think, I guess I'm not super familiar with the beginnings of Crisp DM, but I think this was kind of a natural progression and not like something that somebody dreamed up and was like, this is the ideal way. This is just kind of the way things work because it's the way they need to work.
Yeah, and Jennifer, it sounds like you all use the same process or a similar variant.
It's not as formalized, but definitely the same steps. And I think it's important to realize that evaluation step is iterative with all of your different stakeholders, right? It makes sure that your experts as well as your sponsors are aligned with that evaluation. I think the worst thing would be to have your sponsor see the model when you're saying you're done. Right? They need to be part of that process throughout the entire process of developing it.
Mm-hmm. So, Jennifer, we'll stay with you. At Boeing, what does your NLP toolkit look like? I know you said you're using a limited world of tools over there.
Right. As far as to really start, I think it was either Wes or Johann earlier mentioned about the ontology models, right? So often I'll start doing an ontology model using Semaphore to do the knowledge representation map. And that just allows us to identify what the data is and how it's connected. It allows us to create, if they're not already created, what the relationships are between the various sets of data. And more often than not, we've found that by doing that, then we need to actually go and collect more information, more data in specific areas. So starting with developing your ontology is often where I'll start with, if it makes sense to do that. As far as actual coding environments, doing that, just your Jupyter Notebooks, IDE type of environment, using NLTK for cleaning and tokenizing, that sort of thing. Although as with any package, you need to make sure that you're understanding what's going on under the hood, right? You can use NLTK's, say, word tokenizer or their regex tokenizer. They'll both do the work, but the latter is going to be significantly faster. So understanding what's happening in each algorithm is really important. Otherwise, you might be getting an output and not be able to validate why you're getting that, or maybe it's not going to be maybe doing something in your cleaning before you even get to the actual modeling. I like to use Word2Vec for similarity analysis. Do my networks using Word2Vec. More often than not, it's not as critical to have high accuracy, so I use the NOI indexer. What else? I've used Spacy's tokenizer a bit. their part of speech work is pretty slick, so that's fun to use. Although I find more often than not that I end up not moving forward with that. I use that more in data exploration.
Mm-hmm. And Wes, you mentioned that you use both Python and R. Are you guys a polyglot shop? And if you are, what's your toolkit on both sides of the fence?
As an organization, we are. At the shop, my shop is we're more social scientists, and they're lean more towards R, kind of like it typically happens. And so what we use is we use a platform, I guess I can say the name, Domino, that allows us to kind of work together in an environment where we can develop in Python or in R within the same application and do kind of small batch processing through that. But being primarily an R guy, if I were to drop tools, off the top of my head, tidy text, TM or text miner, text-to-vec, corpus. Those are kind of the more common ones, at least common enough that I remember them off the top of my head, that we would use. One tool that I'll recommend bringing in for somebody getting into NLP and wants to kind of go deep is go out and learn some qualitative research techniques, especially if you're coming from a quantitative background and maybe don't have some of that qualitative knowledge. Understand what grounded theory is. Learn about Husserlian and Heideggerian phenomenology. I mean, those are, when you're examining text, which is kind of what we're doing, understanding how a human would do it and how a human would account for some of the biases can be a really important process, important part of kind of the general understanding on how these things work and where you should possibly use one technique over another.
And Johann, across, you all probably use different tools for different projects, but across, what kind of toolkit do you guys find yourselves using most often, or maybe what piece of the toolkit is making you most excited right now?
So you're absolutely right. Our clients dictate, what we're going to be working on. So it is sometimes it's challenging because they might have some library or service that they want to use, but I would say probably I will break it into two different types. One is just software as a service, and IBM Watson for a long time was really the main contender. Can't tell you if it's because of quality or just market reach. They were first, but I'm starting to see a lot of Google, Microsoft, AWS cognitive services being put in production. So from the services side, a lot of our clients want to build on top of that. Now, there's also challenges with that. Not to mention which one of those providers, but some of these providers will actually take your data and retrain models that they can sell. So for a lot of our clients, that's an absolute no. They don't want to share that intellectual or that data with them. As far as just trusted and tested tools, NLTK, Spacey, we're, I would say, majority Python shop, just because when we do prototyping, a lot of times those prototypes become MVPs or phase one production systems. So Python, just I've also in social sciences used R a lot, but it's not as prevalent in production systems. So Python naturally leads to that. As far as neural networks, it's interesting because I would say TensorFlow and PyTorch, it's like 50-50, and over the past maybe year and a half, 2 years, PyTorch has really been favored, but I think I'm seeing recently, I haven't implemented, some of the folks that I work with have some of the new architectures that's attention-based, where you have transformations, BERT, I'm thinking about GPT-2, that has really changed. And, Google was some of the first folks to actually produce a attention-based architecture that's been put in production. So that is kind of, how I would look at it as services and then trusted testing tools. Now, the one thing Wes was saying that I totally agree with, and that's one of the reasons I went back to school to go study, cognitive psychology, is how people think, how people store memory, how they, interpret information, process it. I think having you don't have to go to college for that, but having a good understanding of how that process happens, it definitely has helped a lot. When you create ontologies and you try and extract meaning from data, it just helps to be able to structure it in such a way that it's, more human-like. So I definitely think as a soft skill or soft tool, understanding how people think and process data how language is processed is very critical.
Yeah, and I think it bleeds into a lot of the tasks, right? I mean, I know one of the tasks that's omnipresent in natural language processing is sentiment analysis, right? And it's this type of pragmatics work, and if you were to do pragmatics work, like linguistics pragmatics work, without computers, you would use all the social sciences approaches that Wes was listing off earlier, and importantly, you can extend those same grounded approaches to look at themes in text that aren't sentiment, and it kind of blows people away when you tell them it's like, oh, you can do more than just tell whether a text is good or bad, and like positive or negative. And it's like, yeah, we can tell whether people are talking about this or that or the other thing or all the things, right? Natural language processing is pretty cool like that.
All right.
Michael, how are we doing on time?
Hello, crew. So yes, so we are at 2:01. Technically, we were scheduled till 2, but I'm going to ask for like 4 to 5 more minutes of our panelists if you can offer it. So I want to fly through 2 things. One thing is the last question, which is what's the future of NLP like? I want to get your quick take on that. And then I want to get to at least, 2 or 3 questions. We'll do them rapid fire from the audience. Okay. So JT, you're right in front of me somehow. So what is the future of NLP within an enterprise setting in your mind?
Yeah. So future of NLP, super bright. Like I said earlier, I think what we're really trying to do with NLP in the enterprise setting is supercharge our knowledge workers. Your super high performers, your super smart people, your doctors, your lawyers, your big thinkers, your engineers, your investment bankers, right? The people who are taking in unstructured information, having to do really, really complex stuff with it, and they're putting out words or advice or recommendations, and natural language processing is in a unique position to make those people more valuable, more productive. And if you're paying somebody, 6 figures, 7 figures, and you can make them, this much more productive, that's hugely valuable for you as an enterprise. And that's what NLP is trying to do.
Yeah, I vibe. Thank you. All right, Jennifer, you're up. Future of NLP enterprise.
Definitely bright light. And second on what JT mentioned, and it's going to start with the infrastructure, right? The promises that NLP provide, and the value that it has to have real insight and actually understand what all this data is, right? We've got gigabytes of data being produced every day, but without NLP, we can't actually pull the insight, we can't pull that information from it. And we've got to have the infrastructure to be able to do that, to connect all those data sources together. So starting with actually building up our infrastructure will not only support the NLP work and providing that information, but will actually support other types of machine learning as well.
The future of it is infrastructure. I'm with it. Johann?
So I have to agree with JT, so I'm not going to repeat what he said, just about making people more valuable. So the second thing that I see that's really exciting is just translation, and not language translation from English to Afrikaans or German or something like that, but think about that same architecture, same methods being applied to natural language, to a structured language like SQL, or a structured business language, where you're able to, again, make people more productive by just speaking. And we prototyped a planning and scheduling application where you would speak and it will basically schedule based on what you were saying, and deal with the conflicts and everything, because that translation happened. And as I mentioned, with OpenAI's GPT-2 and Google's BERT and a bunch of other modern architectures, that translation is becoming much easier to do, much more efficient.
Cool. I love that idea of translating between just normal languages, so to speak. Thank you. Wes, hit us. The future of NLP, what is it?
I guess automating tasks. So similar to what JT had said, and then also to go on Johann as well, we are starting to look at using the translation, and we're using it to translate because we have our part of us is a traditional data analytics shop, and using it for things like automated insights. How do you take this, you've got a machine learning algorithm that runs and finds something, some issue going on, and then can we then turn that into kind of an actual readable text that goes to a business leader, and we're kind of so that our analysts can focus on, more complicated work that requires their human skills and expertise, and not having to kind of chase down that, oh, there was a spike in this one group in this one metric. Instead, the machine itself can just deliver that in a more human consumable way.
I love it. I agree. Okay, now we're gonna jump even more rapid fire to a couple audience questions. So one from Roderick. Hey, Roderick, hope you're doing great. This is for Wes specifically. Do you classify, your NLP processes as like models subject to regulatory model risk management requirements?
Yeah, I could say the OCC classifies it that way, because if it's something that's taking, whether it's text or numbers, and runs computation on that and comes out with and manipulates that in a way that's not, I guess, certain, that creates an estimation, then by those rules, at least our legal department says that, yeah, that's a model.
Cool. Awesome. Thank you. Knock that out. Okay. And here's one that will be a little bit broader. From Franco. Hey, Franco, or Franco. I'm not sure. On the subject of OCR, what do you think are the best practices when dealing with scanned or photographed documents? Do you pre-process the text output from OCR to feed it into models? Anybody go crazy?
So I'll go on that. So I like having I come from a software engineering background. So for me, having something that's composition rather than inheritance is very important. So having a discrete project where I extract characters and then have an NLP project where I extract meaning is how I would approach that than we've done in the past. And it makes it easier for later if you find a better OCR extraction, character extraction model. It's plug and play, and you don't have to re-architect everything.
To follow on that, we've done some OCR work where we're analyzing and detecting maintenance manual or maintenance entries. And the challenge with that is building up the corpus to train it upon, right? You can't go use those public corpuses because of the type of part numbers and part names and the nomenclature that we use internally. So while it's capable of doing that, building up the corpus to do the training on becomes basically challenging.
Cool. Anyone else? OCR? Once, twice, thrice? All right. I got one more here. From Brennan. Thank you, Brennan. Are any of the panelists doing like project or program performance predictions with NLP models?
No, I can say that it's come up. It's been talked about when they're looking at productivity, and our current discussion is to get them to understand productivity for especially the knowledge worker class, and how kind of the old industrial thinking of producing widgets is an inappropriate way of even asking that statement. So more to come for me on that as we continue to have those conversations.
I'd say that one of the interesting applications of NLP that I've seen is comparing. We know that you can compare two documents, but you can create like NLP judges for documents. So if you have documents that have to be of a certain quality, say you're a newspaper author, right? And you've got a staff full of writers, and sometimes they write you stuff that's not very good, and you have to spend a lot of time editing it. You can train a natural language processing system to judge how good a news article is. You can train a natural language processing to judge how good an academic article is, or an engineering report, right? And that can help make your engineers or your journalists or your academics better, because now they have a clear target to shoot for, where before they would have to send it off into the ether, and they would get kind of amorphous feedback from whomever their editor was, or what have you, right? And so this isn't necessarily predicting the performance, but it's assessing how something would be rated by a human judge. And it really because every knowledge worker is capable of looking at a green or red light and seeing when it's green, or unless you're colorblind, you can still tell. but yeah, it helps in that respect, but it's on the input side, not necessarily on the projection side.
Cool. Thank you. That's very interesting. Yeah, Johann, I see your hand up, I think.
Just quickly, we haven't worked on it, but actually one of my coworkers is working for a company called Pinpoint, and they do exactly that, where they do performance intelligence on code, for software engineers. That basically bubbles up into management reports and productivity reports. So I think there's a couple of companies out there that does that kind of measurement where they have plug and play tools, specifically around knowledge workers, programmers, software engineers, things like that.
Cool. Pinpoint. All right. So maybe that'll be a good lead. All right. And with that, I'm going to have to stick a fork in it. Thank you so much, everyone. JT, you crushed it. You were awesome. Jennifer, Johann, Wes, amazing panelists, great perspective. And thank you to everyone, for sticking around. I hope it was valuable for you. And yeah, Godspeed in your AI endeavors and stay healthy out there.
Thanks, Michael.
Thank you.
Take care, everyone. Thanks for joining.
Bye, everybody.